Anyone with a GT3B that's ever wanted to run high voltage servos have probably quickly found the receivers just can't handle higher voltage. They are rated to 6.5 volt max. That's fine for a 4-pack AA input, a 6 volt BEC, or a 2S Life battery. But if you want to run high voltage servos, you have to run 2 batteries and are annoying wiring. This mod here can fix that, making it compatible with 7.4 volt or 8.4 volt BECs, or direct input from a 2S LiPo battery. So, how does a servo work? Each servo lead has 3 wires, voltage in, ground, and servo signal output. The receiver does not output voltage to power each servo, it just shares the same input voltage source and sends a control signal. That control signal is a low voltage PWM signal with a varying 1 to 2 millisecond pulse width. The reason the GR3E can't take higher input is an ME2108A50M3G boost converter. It's great for alkaline or nickel metal battery packs as it works all the way down to around 3.5 volt, but it's limited to 6.5 volt max input. If you run it on 7.4 volt or 8.4 volt, it might fail instantly, or it might fail later. Either way, it's well outside the ME2108 spec. Here in these diagrams you can see the chip labeled D4YS. This is the ME2108. Battery voltage comes in here at the bottom right leg through an inductor on the other side of the board. Then 5 volt comes out from the top leg and goes to a 7333 LDO. Note the pinouts, the input and output are not in the same position. To resolve this, we only need one new component, which is a 7550 LDO. Firstly, we must open the transmitter, then remove the ME2108 converter, the inductor, and the Schottky diode. Then install the 7550 LDO regulator instead. The pinouts for voltage in and voltage out for the 2 chips are different, so we must install it in a slightly weird position. Next to here are also our input capacitors, the larger of the yellow ones at the top, and the small ones slightly to the left of the unused pad where the old boost converter was. They are rated at 10 volts, which will be the new voltage limit for this receiver. Make sure you have strong solder joints, as RC equipment can be subjected to a lot of vibration. Clean up around the newly fitted LDO and then flip the board over. On this side, we need to remove the diode and inductor. The diode is small, so try not to lose it. It can be reused for reverse polarity protection. Otherwise, you can just run a bridge across where the inductor pads are. I would recommend having the diode, so if you need to get a replacement, use a Schottky diode like a 1N5817. Tape over the button with Kapton tape to prevent damage. There is glue over the inductor and diode here, keeping them together when removed, but may not be there or over both components. This glue is likely to keep the inductor protected and is no longer needed. Take note of which side the line on the diode is. The side with the line is the cathode and must be towards the crystal oscillator as shown. Once again, make sure you have strong solder joints. The bottom pads where the diode was will be left empty. Check with a multimeter in diode mode. Positive probe on any middle pin of the input connectors and black probe to the diode. The left side should show 0 volts dropped and the right side approximately 0.2 volts to 0.3 volts. Now the receiver runs an LDO regulator that can tolerate the higher input voltage. It now has a minimum input of around 5.5 volt and a maximum input of 10 volt. Reassembly is simple, just put the board back in and the cover back on while making sure not to pinch the antenna. Then install the 2 screws. Testing the receiver, you can see that the servo control signal is good and remains the same.